In this screencast, we're going to explore the InexactUnitCalculator class. The class is used to control the relationship between the Java Swing user interface elements and the methods that actually do the work inside of the program. Let's take a look at how this controller class works. The first thing that we notice is that this class extends JFrame. Therefore, it inherits all the information about JFrame, which is used to establish the user interface and manage the relationship between Swing objects and the program's methods that implement the various actions. The class contains a number of attributes. Each of these attributes are involved with specifying aspects of the user interface. So let's take a little look at the user interface to get a sense of the things that we're going to be managing with this controller object. So here is the user interface. This is the actual program running. And we have a number of messages like this title here, these labels here, this plus and minus sign, the word units. We have these text areas where information can be entered. This is an output area where messages or information will be placed based on the results of the computation. And we have these combo boxes that are used to specify units. So let's take a look at how each and every one of those elements on the user interface have been represented inside of the controller object. The first thing that we notice is that the controller object specifies information about the window width and height. The width and height, this frame size, is the size of this window right here. Down here later on, we'll see that there is a declaration of the screen size. That is the actual size of the computer screen. The reason that we do this is to make sure that when we start up the application, that we can position the window in the middle of the screen. These private values are used to give us certain characters that are not easily available on the keyboard. The plus or minus sign on the user interface. This is the plus or minus. In the case of powers of 2 and powers of 3, those characters, as we see here, come from access to Unicode. And what we're doing is we're specifying Unicode values here as the code that is being used to specify what the characters are. So in this case, plus or minus string is a plus or minus followed by a blank. And here, power 2 is just this code representing the power 2. And we can see that right here, we have millimeters followed by the power of 2 character, centimeters followed by the power of 2 character, and so on and so forth. This attribute specifies the sequence of labels for the various units. This is used in the combo box here. And so the sequence as they show up here is precisely the sequence as they appear here. This collection of Java Swing user interface elements establishes the objects that are used to specify the kinds and locations of the various user interface elements. So this message here, the message integer calculator, is a label that specifies the text string InexactUnitCalculator. If we change that, that changes this label on the user interface. Similarly, the message labeled units is a label that specifies units, which is this label right here. When I created the program, I developed a protocol of using MSG to describe a fixed message that is not altered. FLD is a field which is used for input-output. BTN is a button. ERR is an error message, which is turned on or turned off based on whether or not it is needed. And so this naming scheme helps me remember what it is that I'm looking at just by looking at the name of the variable. So each of these attributes represents a different element of the user interface. So this JText field operand 1, is this text field right here. That plus or minus sign is this one right here. So we have a message that is used to label the amount of the error, the uncertainty for operand 1. The combo box associated with operand 1 is this item right here. And notice that it uses unit names is the list of labels that specify the various values for the combo box. And that's what unit names is right here. So this combo box refers to this array of strings which populates that combo box. These attributes here specify information about the various operands, the various elements of the calculator. So this is operand number 1. And so this object, this calculator value, which is explained in a separate screencast, that operand 1 represents all or encodes all 3 of these values, as well as a set of methods that allows us to perform meaningful operations on those 3 things as a calculator value. This object, operand 2, represents this value here. The result represents this value here. These 4 buttons are the actual J-code or the swing graphical user interface elements that define these 4 buttons. And the value of those buttons is not placed into a variable, but when a button is pressed, the controller object directs execution to an appropriate routine. And we'll see how that linkage is done in just a few minutes. These 2 variables encode the state of these 2 combo boxes. And we'll see how that linkage is established later as well. When the user changes something in an editable text area, there is an event is generated. And in order to capture that event and process it, we establish a document listener. A document listener is a kind of object that is used to wait for events and then deal with them. Each document listener consists of one of 3 kinds of actions. One of them is that a particular document has been updated. And so that is dealt with here. And so in the case of a change or update, we invoke this method. In the case that we insert something into it, we invoke this method. And in the case that we remove something, we invoke this method. Now, you'll notice that in this case, any change, whether we create something, we insert something, we remove something, or we change something, we're going to exactly the same method inside of this object, the check for errors. And so basically every time you change any of the operands, we go to the same method to verify that everything on the user interface is still valid. This is actually an important point because there is compatibility between things that need to be checked. So we need to make sure that things are consistent across everything. And so rather than just checking one field, we're checking all the fields every time anything is changed. This method is the constructor for the class. Remember, when an object is instantiated, things get initialized in two steps. The first thing that happens is all of the attributes are instantiated based on their declarations. So when this object is created by the main, it establishes all of these particular attributes and initializes them based on these declarations. So this attribute, button add, receives a new value based on creating a new J button and then pointing or referring to that by means of placing the reference inside of this variable. So that basic initialization takes place before the constructor is called. After all of the declarations for all of the attributes have been processed, then the constructor is performed. And you will see that we now perform a number of other kinds of actions. We set the title of the window to, in this case, my name. We set another indication that when the close button is clicked on the window for this particular J-frame, that the program will exit. And so when the window is closed, the program exits. You can set it so that other actions will occur as opposed to exiting the program. So for instance, if somebody closes this window, you could open up another window and initiate a dialogue with the user wanting them to do possibly other things. Then what we're going to do is specify, or what the program does is specify a number of specific details about the various user interface elements. So in this case, we're setting the font for this particular message, and we're specifying where it's to be located on the inside of the window. And so this location is specified by these four attributes. We do the same thing with the rest of the objects. So here is for the message units, the font, and where it's located. Message operand 1, so this is the label for operand 1, and so on and so forth. So for each of the various graphical user interface elements on the screen, we specify information about it. In the case of field operand 1, this is specifying what value should be inside of this editable area when the window starts up. And so we're saying we want that particular text field to be empty. We specify what font will be used when people type into that text area. We'll specify the size of the text area. And then this is where we associate a document listener for this particular text area. So this field change listener is precisely this field change listener here. So anytime any change is made to this field, this association that we're performing right here between this object, this field change listener, and this field says that whenever a change is made inside of that field, we're going to invoke this method to go do something about that. This establishes the units, which is the combo box. And so if we take a look at field operand 1 units, we'll see that it was declared here as a combo box. We specified in this declaration that it uses this array of unit names. Now we need to specify a few more things about it. So we specify the font, we specify where it's located on the screen, and we associate a listener so that when you change that value, that we specify what routine should be invoked in order to appropriately process that change of the combo box. And this is the name of the method inside of this particular object. This method will be invoked when you change that combo box. So remember I said we would see a little later when this unit 1, how that gets set? Well, that is set by this method that we looked at right here. So this method, set units 1, is actually, so let's go down and find set unit 1. So here, set unit 1. So this method sets unit 1 and then checks to make sure that everything else in the user interface is valid. This sets up an error message. Notice that it's setting the color to red, so that if we make this error message visible, if there's a definition for the error message, currently the message is blank or empty, and so therefore nothing shows up on the screen. But if we set the text to some specific sequence of characters, those characters will show up at this location on the user interface, and they will be shown in red. And so this is appropriate for an error message. This set of declarations are exactly the same sort of thing for operand 2. And so again, we're setting some labels. We're setting the text area for the operand. We're setting the label for the error term. We're setting up the input for the error term, the uncertainty amount. This sets up the combo box for the units for the second operand, and this sets up the error message for the second operand. This area is where we define the buttons. So we declared the buttons before. This is where we put the label inside of the button. Here we set the font that is to be used for that label. We set the bounds, which determines the size and the location of the button on the window. And this is the code that specifies what method inside of this class should be performed when the button is clicked. And so you see that we're going to perform the add operands method when the plus button is pressed. We will perform the sub operands method when the minus button is pressed, and so on and so forth. This is where we're setting up the details about the result. So we specify the message for the result, its font, where the message is located, and that we want to change its alignment to be right justified as opposed to left justified. So therefore we want this result field here to be adjusted so it fits next to this, and that the starting point varies. Depending on the operator that you perform, if you put plus, this will change to the word sum. If you click minus, this will change to the word difference. Multiply, this will become product. This will be quotient if you click on the divide. So that result message is used to capture those. And since each of those are different size, we need to set the alignment to right so that the last character is in the same place and not worry about where this first character happens to start. This sets up the information about the text. Notice that this is not editable, so I'm allowing the user to cut or copy and paste the text, but the user is not allowed to actually change the results by directly typing in them. This is the error message associated with the result, and this is primarily used for units mismatch, where it's not necessarily that the operand 1 is wrong, and it's not necessarily that operand 2 is wrong, but the result can't be computed because one is not compatible with the other. Now that we've declared each and every one of these user interface elements and given specific information about them, these commands are then used to take each of these various user interface elements and place them into a content pane. Now we are managing the layout of the window explicitly and manually. We're not using a piece of software. A lot of Java Swing books and articles are designed to support the idea that when you resize the window, that the layout manager can reposition the graphical user interface elements, very much set the way that a web page reorganizes and redesigns itself. That's fine for many applications, but there are often the situation where you spend a great deal of time producing a specific look and feel. And so the way we specify that we are going to manage the layout is we set the layout to null, saying we are going to manage it. Otherwise, you would set the layout to a reference to some layout manager who would be responsible for deciding where to move things to in case the window is resized and some of the items that would have been obscured no longer in the window because of the resizing, that those things need to be moved. We are going to manage the layout ourselves, and therefore we use the word null here to indicate there is no layout manager. So we add all of the various user interface objects to this content pane. Then we determine where the middle of the screen is and position the location, the size and the location of the window to be in the middle of that screen. And then we make this particular window visible. And at this point, the window appears on the user screen, and we're done with the constructor. And at this point, the thread of execution that began with the main basically comes to an end. But we've established each of these graphical user interface elements and a number of methods. And when one of the user interface elements, when the user interacts with them by either typing in them or clicking on a button or selecting an item in a combo box, that it generates an event, and one of those events is then handled by one of the methods that follows below. And so therefore, the fact that this initialization thread comes to an end, the program is still running in the sense that it is waiting for the user to do something. So this is a very different style of programming from the kind of programming where the main line is constantly running and asking the computer for input from the user. In this particular case, the program puts itself basically on pause, waiting for an event to occur, and as soon as an event occurs, then one of these methods is going to be initiated. So let's take a look at the methods. One of the first methods is the convert operand 1. When you type into one of the input text areas, you're typing characters. But when we're going to do operations, in this case, work with floating point values, we need to convert them from a sequence of characters into something that can actually be manipulated by the various operators that are used inside of the program. So if we're going to perform addition, subtraction, multiplication, and division, in this particular instance of the calculator, we're going to be doing that using double arithmetic. So this convert operand 1 is used to convert an operand from a sequence of characters into a double value. This operation reaches into field 1, that graphical user interface element, and gets the text from that particular input field and places it inside the string variable temp. If there are indeed characters there, then we come down here. But if the size is 0, if there are no characters, then we perform a number of reset operations and we return a 0 value. So maybe the action that occurred was to erase things, and so now this action, since the input is empty, needs to be to set up so that that everything is reset and we're back to basically the equivalent of an empty input. If indeed something is there, then we start at character 0 and begin the process of seeing what's there. We assume that the input is positive, and then we check to see if the user has given us a plus sign. If we've given a plus sign, then we increment start to effectively ignore it because we already have assumed that the value is positive. But if the user has specified a negative sign, then we increment start to ignore it, but change the value of this Boolean to be true so that when we actually create the value, that we know that we're going to negate it to change it from the positive value that we were going to create to a negative value. We then use a scanner to scan the rest of the input screen. And so the temp was established here. This takes a substring at the start location, which does not include a sign. So therefore, the start is the first, should be the first digit of the character sequence. So if the scanner finds that it has a double value starting at this location, then we're going to not perform these operations. So there's the not. So if we have indeed a double value, we're going to come down to here. If it's not a double value, we set up an error message. Now that error message text area had been empty, and so therefore nothing was displayed on the screen. As soon as we change it to have some characters, then those characters will appear in the appropriate place on the screen as defined above, and they will be shown in red. This message indicates that we have an error condition, and error conditions are checked in various places to make sure that we don't perform operations when there are errors. And because this method needs to return a value, we return a 0. So in case there is an error, the method is going to return a 0 value, but this error message indicator right here should make sure that that 0 is not actually used for anything. If there is indeed a double value, then we convert the input to that double value by using the scanner and next double. And then we check to make sure that there is nothing following it. If there is something after the number, then we issue an error message that there is excess data in the input, and we return 0. If there is no error, there's no additional data after the valid floating point value, then we initialize these particular inputs. We initialize the result field, because if you change one of the operands, then the former addition, subtraction, multiplication, or division is no longer meaningful. And so therefore we reset the result field text area to make it empty, and we reset the error message associated with the result. And then if the number is negative, we return the negative of the value that was computed by the scanner. And if the value is not negative, or in other words, if it is positive, then we just return the value. And so this is how we process operand number 1. This is where we deal with the uncertainty value. Now, the uncertainty value is a double, just the same as the calculator value, but the only real difference is it should be a relatively small value in terms of not very many significant digits. So the structure of this particular convert routine is going to be very similar to the previous one, but as you see, it's a little shorter. We're interested in just a positive value, and so we're not going to deal with the issues of plus and minus signs. So again, as before, if the length is 0, we return a 0 value. If it's not 0, then we check to see if there indeed is something there, and if that something there is a valid double value. If it's not a valid double value, we issue an error message and return. If it is a valid double value, we get that value, We then check to see if there's excess data, and if there's not excess data, then we return the value. This method, convert operand 2, does the same as convert operand 1, but it uses field 2 as opposed to field 1. Otherwise, this method should be exactly the same as convert operand 1, so we won't spend any time looking at it. Same thing for convert operand 2 error. This deals with the uncertainty code input field for operand 2, and it should be identical to the uncertainty code for operand 1. So here is the method check for errors. Remember check for errors before? Check for errors was used any time we saw that there was a change in any of the input text areas. So what we do is we assume that there is no operand error. Then we reset the result to back to the word result. It might have been sum or difference or one of the other result names. So we set it back to the word result. So anytime you change an input, we basically invalidate the old result. Then we process operand 1 and we process operand 2. And the way we process it is by creating a new calculator value, and we'll have a separate screencast that describes that particular class. And we pass in 3 operands. We pass in the result of the value, we pass in the result of the uncertainty amount, and we pass in the units that are used for that particular operand. So as we said before, and actually if we take a look at this operand consists of 3 things: this value, this uncertainty, and this units. And that's precisely what we see here. There's the value, the uncertainty, and the units. Same thing for operand 2. So checking for errors is setting things up so that we can perform the various actions. Setting unit 1 and setting unit 2, this is the handler, the event handler, that processes any attempts to change the combo boxes for the units. So this process, this code here is performed anytime that the user changes this combo box. This code here is called anytime the user changes this combo box. These methods are used to process the actions of clicking on the various buttons. There are 4 buttons on the user interface: add, subtract, multiply, and divide. And there are 4 methods inside of this class. Here's the add operands, subtract operands, multiply operands, and divide operands. And that's the end of the class. So let's go back and take a look at add operands. Add operands is past an action event, which gives us information about the event that was generated that caused this particular method to be invoked. We don't particularly care about that in this program, so therefore you'll see that we don't actually use the parameter inside of the method. If there is an operand error, then we immediately return without doing anything else. And so as we said before, if there is anything wrong with either operand 1 or operand 2, then clicking on the add button does nothing. Another way this could have been processed was by disabling the button, so if there were error conditions that you couldn't even have clicked on it. But we elected in this program to go ahead and allow the button to be active, but the first thing that we do is to make sure that there are no errors. If there's an error, we just simply return. If there isn't an error, then what we do is we reset the error associated with operand 2 in case there might have been a previous divide by 0 error displayed there. We then perform an add operation. So we invoke the calculator value class, and ask it to perform an add operation of operands 1 and operands 2, putting the result here. So we're using this concept of a calculator value object to add, in this case, two calculator value objects together. So we want to add operand 1 to operand 2, producing a result. Then we use this command to convert that result to a string and place that string inside of the text area of the result field. So that method call right there will cause something to appear in this window. We then put the message sum into the result area. So this word result will be changed to sum. And remember, we had set a right justify, so the M will be right there. And then if we check the units to see if the units, if there's a units mismatch. And so if we get a value, a negative value from this get units, a -1 in particular, then that tells us that we don't have an appropriate relationship between the input value and the two input values, the two operands. So get units returns the index that is going to be used for the result, and if that value is negative, then we don't have the result that we would be able to express appropriately. So therefore we give an error message. So if you try to add meters to kilograms, you should get a units mismatch. In the case that it's meters to meters, then we will get the result being meters. So here's the add routine. Here's the subtract routine. Subtract is very much like the add. It's just that it invokes the subtract method as opposed to the add method. But otherwise, you can see the flow of the code is exactly the same. In case of multiply, again, we invoke the multiply method as opposed to the subtract method. And the only one that's really different is the divide, because we have to check for divide by 0. Now the awkward thing here is that how close to 0 do you need to get before we decide that it's a divide by 0? So we have unilaterally decided that if anything is less than 1 times 10 to the minus 50th, we decide that anything that is less than that, closer to 0 than that, will be treated as 0 for the purposes of a divide by 0. Now, for certain applications, that may not be appropriate. But other than that, this routine is very similar to the others in the fact that this is the body of the code right here. And so here's the divide, here's the convert to string, setting the quotient message, and determining whether or not the units mismatch message should be displayed or not. And this is the end of the Inexact Unit Calculator class. I hope this review of the code has proven useful to you.